College Board 10, calculator allowed number 26. In this scenario, we have Keith, who's modeling the growth over several hundred years of a tree population by estimating the number of trees' pollen grains per square centimeter that were deposited each year within layers of a lake's sediment. All right, that's a big mouthful there. Turns out that the important stuff doesn't happen until this next sentence. He estimated there were 310 pollen grains per square centimeter the first year the grains were deposited, and a 1% annual increase in the number of grains per square centimeter thereafter. So really, this information is enough to come up with an exponential model. That exponential model is going to be P of t is equal to, we start out with 310 grains of pollen, and then we have to understand how to interpret this 1% annual increase. And this 1% annual increase, the idea is that each year that goes by, we have 100% of the pollen from the previous year plus 1% more than that. As decimals, 100% is the number 1, and 1% is the number 0.01, or 1.01. So whenever we have a percent change problem, instead of like a constant rate of change that would be a linear model, a y equals mx plus b, a percent change problem, in this case a percent increase problem, is exponential. We're going to take 1.01 raised to the t power. And so if we want to figure out which answer choice that matches up with, it goes with D, and that's our answer. You don't want to pick something like C. That would be a percent decrease problem. 99% would be 100% minus 1%. So that's if the pollen was going down each year. And then A and B just aren't proper descriptions of how an exponential model works. When you're doing exponential modeling, you have y equals y naught times your percent increase added to 1, so 1 plus your rate of increase raised to the t power. That's an exponential model.